Hello, welcome to TGM tutorials. In this tutorial we shall look at lesson 5, which is computing 3x3 determinants using elementary row operations. Okay, for elementary row operations and 3x3 determinants, you have to know the following. If B is a matrix obtained from 3x3 matrix A by applying the elementary row operation, this operation, the determinant of B, so if we apply this operation, row I is equal to 1 over k multiplied by row I. The determinant of B should be equal to k multiplied by the determinant of A. For example, if we have A, which is equal to 4, 2, 4, 6, 1, 0, 2, 4, 2, negative 1, 3. If we apply the operation row 1 is equal to 1 over 2 row 1, we are going to have this resultant matrix 1, 2, 3, 1, 0, 2, 2, negative 1, 3. This operation is only being applied to row 1. We are dividing every entry in row 1 by 2, and we are getting 1, 2, and 3. Okay, so the determinant of this resultant matrix, let's say this resultant matrix is B. The determinant of B should be equal to, here we divided everything by 2, should be equal to multiplying the determinant of A by 2. That is what that property means. Okay, the determinant of B should be equal to 1 over 2 multiplied by the determinant of A. Let's look at the second property. If B is a matrix obtained from 3x3 matrix A by applying the elementary operation, row 1 interchanging row I and row J, then the determinant of B is equal to the negative determinant of A. I want you to notice something, that these properties, they are just similar to the properties of 2x2 matrix when carrying out determinants using elementary row operations. They are just the same. If we have a matrix A, interchanging two rows will give us that. If we say that is matrix B, the determinant of this resultant matrix B should be equal to the negative determinant of matrix A. For example, the determinant of matrix A is equal to 2. Let's find the determinant of B. The determinant of B is giving us negative 2. So if the determinant of B should be equal to the determinant of A, then we have to multiply negative to the determinant of A. Therefore, determinant B should be equal to the negative determinant A. Okay, if B is a matrix obtained from 3x3 matrix A by applying elementary row operation, this operation, the determinant of B should be equal to the determinant of A. Okay. Like 2x2 determinants, 3x3 determinants have the following additional properties. If A and B are n 3x3 matrices, then the determinant of AB should be equal to the determinant of A times the determinant of B. If A is a non-singular 3x3 matrix, then the determinant If A is a non-singular 3 by 3 matrix, then A inverse, sorry, not determinant, this should just be, removing that, A inverse should be equal to 1 over determinant A. If A is a 3 by 3 matrix and n is any integer and n is integer, then the determinant of A to power n is equal to the determinant of A in brackets raised to power n. Okay, those properties are very easy. We proved them using elementary row operations on 2 by 2 matrices. Let's do this activity. We are finding the determinant of that matrix using elementary row operations. Let's do question 1. Okay, elementary row operations are carried out in order to deduce a matrix to an echelon matrix. So here where we have, in this column, we should make sure that we have a 1 here, a 0 here, a 0 here, and a 0 here. Okay, or we just have a 1 and a 0 and a 0. Doesn't matter with the rest of the entries. Okay, so the first operation that we are going to carry out, we are going to make sure that in this column, in the first column, we have the same entries. So what operation can we apply to this in order to have the first column with same entries? Here I want you to notice that, okay, this should be Z, not X. This is Z, not X. Okay, here I want you to notice that in the first column we have YZ, ZX, X, and Y. Here the only thing missing is X to make X plus Y plus Z. Here the only thing missing is Y, and here the only thing missing is Z. So we are going to add row 1 and row 2, column 1 and column 2. So the operation that we are going to carry out will be column 1 is equal to column 1 plus column 2, and that will give us X plus Y plus Z, X plus Y plus Z, X plus Y plus Z, X, Y, Z, X cubed, Y cubed, and Z cubed. Having that, we are going to factor out X plus Y plus Z in column 1, and that should give us X plus Y plus Z multiplied by the determinant of 1x, X cubed, 1y, Y cubed, 1z, Z cubed. Okay, now we have a 1 as the leading element in the first row. We are going to make sure that here where we have 1 in the second row and 1 in the third row, we have zeros. So the operation we are going to carry out will be row 2 will be equal to row 2 minus row 1, row 3 will be equal to row 3 minus row 1. Okay, if we do that, we are going to have X plus Y plus Z multiplied by determinant of that. Here we have Y minus X, Z minus X, Y cubed minus X squared cubed, Z cubed minus X cubed. Okay, now since we have 1 as the leading element here and the rest are zeros, we can now delete this column, this row, and this column, and we will remain with this matrix, resultant matrix. Now in this 2 by 2 matrix that we are going to factor out in the first row Y minus X, because it is common. If you factor out in the first row y minus x, and in the second row y minus x, z minus x, we are going to have y plus x plus